Very good morning to everyone. Let us solve some problems regarding to concave mirror. As we already discussed, what is mirror formula, sign convention rules, magnification, how we can find the magnification, height of the object, height of the image. So all are already we discussed. So let us calculate some problems. So problems are also very important for in our chapter. So let us take the first problem. Find the size, nature, position of image, form when an object of size 1 centimeter placed at a distance of 15 centimeter from a concave mirror of focal length 10 centimeters. So let's read the problem again. Find the size, nature, position of image when an object of size 1 centimeter is placed at a distance of 15 centimeter from a concave mirror of focal length 10 centimeters. 10 centimeters. So, first of all, we have to find the image. Before that, let us write the given values. Solution. First of all, write the given values. Given values. Uh, height, height, height of the object. Height of the object HO is equal to 1 centimeter. 1 centimeter. Then see where the image object is placed at a distance of 15 centimeter from a concave mirror. So object distance U is equal to 15 centimeter. We have to put 15 minus 15 because of as we learnt in the sign convention. So object distance always negative. Then what is the focal length? Focal length F is equal to 10 centimeter. As we know, the mirror formula, focal length also should be taken as a here minus, right? So from the mirror formula 1 by f equal to 1 by v plus 1 by u. So we know mirror formula 1 by f equal to 1 by v plus 1 by v. So let us find the where the image of an object is formed. At what distance the image will be formed, right? So from that we can write 1 by v is equal to 1 by f minus 1 by u. That is equal to, substitute the values, minus 1 by 10 minus of 1 by 15, minus of minus 1 by 15. So that is equal to minus 1 by 10 plus 1 by 15. 1 by 15, that is equal to, let us wait, after calculating the LCM we get 30 as LCM. So 10 3 jar 3 minus 3 plus 2 jar 2, that is equal to minus 1 by 30, minus 1 by 30. So 1 by v is equal to minus 1 by 30. Then we can write v is equal to minus 30 centimeter. Minus 30 centimeter. That means the image is formed at 30 centimeter in front of the in front of the mirror, in front of the mirror. So this is the what we have to find, position of image, position of image we can find out. Then as we know, focal length is 10 centimeters, so image distance 30 centimeters, objective distance 15 centimeters. So image where does the image of an object is formed, right? The image is formed at 30 centimeter. So now as we know, concave mirror mostly form real and inverted images. Real and inverted image. Nature of the image. Nature of the image. And what do we have to find? Size. Size. What about the size? Let us calculate the size of the object. Height of the object is given for us 1 centimeter. 1 centimeter. So size of the image, to calculate, to know the size of the image, we need to calculate, we have to know magnification. Magnification m equal to, magnification m is equal to, we know the formula, minus v by u, minus v by u. So u means object distance, we know 15 centimeter, image distance we know 30 centimeter, 30 centimeter. Let's substitute the values, minus 30 by minus 15. So minus of minus 30 by, so then we get minus 2 centimeters. Magnification is minus 2. Magnification is minus 2. And we know magnification m is equal to height of the image, height of the image by height of the object. So we know height of the object, height of the object is equal to 1 centimeter. Already the problem given 1 centimeter, 1 centimeter. So height of the image is equal to m into height of the object, that is equal to minus 2 into 1, that is equal to minus 2 centimeters. So magnification, sorry, not magnification, image. So the size of the image is equal to, the size of the image is equal to minus 2 centimeter, minus 2 centimeter. That means real and inverted image, as already we discussed, real and inverted image in the sense it forms below, it forms below the principal axis, it forms the below principal axis. If we draw a simple diagram, right, a concave mirror, as we know this is the pole. So if it is the focal length, then it is the focus, it is the focal length, here the center of curvature, where the image is formed, object focal length r is equal to 2f kada, r is equal to f, and here is the object placed between focal length and center of curvature. So passes through focus, then other one. So forms behind the mirror, forms behind the mirror. So object distance 30 centimeter, image distance 15 centimeter, 15 centimeter. So object, the position of the object may be in between um, right, in between center of curvature and the focus. So in this way the problems will be asked in the examination. We must have prepared practice many problems. So hope understand. So once again see, find the nature and position of the image formed an object size placed at a distance of 15 centimeter from a concave mirror. First of all, let us write the given values, then use the correct formula. Simplification is your wish, but answer is must. Follow sign convention rules. As already we discussed, what are the sign convention rules? Sign convention rules must be followed. Okay, then take the second problem. An object 20 centimeter high is placed at a distance of 16 centimeters from a concave mirror which produces a real image 3 centimeter high. What is the focal length of the mirror? Find the position of the image. Before that, as usually, first of all, we have to write the given object size. Object size or height of the object is HO is equal to 2 centimeters. Then object distance, object distance U is equal to minus 16 centimeter. Then what we need to find? Focal length and find the position of the object. Then for us a real image is obtained. Real image is obtained. So size of the image or height of the image is equal to 3 centimeter. So first of all, find the position of the image. Position of the image. To know position of the image, we have size of the object, size and the size of the image. So magnification formula we have to use. Magnification M is equal to height of the image by height of the object. That is equal to height of the image 3. Then height of the object is equal to 2. Height of the object is equal to 2. So height of the image is taken as the minus because of a real and inverted image formed, which is generally below the principal axis. As per the sign convention rule, uh, if the image is formed below the principal axis, we have taken as a negative. So minus 3 by 2. Minus 3 by 2. That's it. After simplification, we get minus 1.5. Magnification is 1.5. Then so we have one more formula about magnification. M is equal to minus V by U. Minus V by U. That is equal to, that is equal to, from this we can calculate, that implies image distance V is equal to M into U1. M into U1. Magnification minus, so object distance also minus. So substitute the values now. Substitute the values. So V is equal to minus 1.5 into 16. Minus 1.5 before. So minus of V by minus 16. Minus 16. So minus minus get cancelled here. Remaining value we have V by 16. M value minus 1.5. So simplification After simplification, we get 24 centimeter. So image distance is 24 centimeter minus 24 centimeters. So image distance we know. So where the image of an object is formed at 24 centimeter. 24 centimeter. Then the next one, calculate the focal length. Focal length. Focal length. Formula we know. Mirror formula 1 by f equal to 1 by v plus 1 by u. So as image is formed 24 minus 24, 1 by 24 plus of minus object minus 16, minus 16, right. So minus 20 minus 1 by 24 minus 1 by 16. So when we take the LCM, so 48 will get. So 24 2s are minus 2, 16 3s are 48, 16 3s are 48. So that is equal to minus 5 by 48. 1 by f equal to minus 5 by 48. So from this we can write focal length is equal to focal length f equal to minus 48 by 5. So when simplify, 5 9s are 45, 5 9s are 45. So 9.6 centimeter. So the focal length of the mirror minus 9.6 centimeter, and the image is formed at 24 centimeter, 24 centimeter. So we are calculated the focal length of the mirror. Focal length of the mirror is minus 9.6 meter. Then find the position of the image. The image is formed at 24 centimeter. 24 centimeter. In this way, we have to calculate the problem. So you must know the sign convention rules. You must know sign convention rules and formulas. Mirror formula, magnification formula. So magnification formula we have two. One is magnification m is equal to height of the image by height of the object. Then one more formula is minus image distance by object distance. So by keeping these two formulas or three formulas, then we are able to solve the problems very easily. Understand the problem first of all. So what are the values are given, what we have to find out, right? Example problem, I am sorry, already solved problem. I am showing you sample problem. A concave mirror produces 3 times magnified real image real image of an object placed at 10 centimeter in front of it, where the image is located. In this problem, see, magnification given directly in the problem. Enlarged image, magnified object distance given, find the image distance. So magnification formula, by putting the values in the magnification formula, m equal to minus v by u, magnification we know minus 3, v by minus 10. By simplification we get the image is located at 30 centimeter in front of the mirror and left side, 30 centimeter of the image left side. So simple problems, but practice is required. Without practice, it is very difficult to solve the problems. So read the problem carefully, and we need to solve it. Use the correct formulas, write the given values correctly, use the formulas correctly, substitute the values correctly, and simplify it. Then you are able to understand the problems. So in this way we practice all the problems. Thank you.